Katie has basketball practice 2 days a week. 92% of the time she attends both practices. 6% of the time she attends one practice. 2% of the time she does not attend either practice. Complete the probability distribution table first. Okay, so we're just going to fill it out. The X values are already filled out for us. Those are the possible outcomes. So she could attend 2 practices, 1 practice, or 0 practices. We need to assign the probabilities. For this particular problem, they give us the probabilities. So 92% of the time, she attends both practices. So 92% of the time, she attends 2 practices that week. As a probability, in decimal form, that'd be 0.92. 6% of the time, she only attends 1 practice. So that'd be 0.06 as a decimal. And 2% of the time, she does not attend either practice. So she attends 0 practices 2% of the time, so that's 0.02 as a decimal. Okay? So we got the probability distribution table. Next, we want to calculate how many practices we should expect Katie to attend any given week. So that's the expected value. That's the key word here. Okay, if we had to guess based on only this information, our best guess would be the expected value. Okay, so let's calculate that. Let's put the relevant information into the calculator. So X is, my possible outcomes are 2, 1, 0. She can attend 2 practices, 1 practice, or 0 practice. And the probability of those outcomes, probability that she attends 2 practices is 0.92. Probability that she attends 1 practice is 0.06. Probability that she attends 0 practices is 0.02. Again, notice that I am keeping the order the same. When the outcome's 2, for the first outcome, that's also the first probability. The second outcome has a second probability of happening. The third outcome has a third probability of happening. It's important that you keep the orders the same here. Okay? So now our expected value, I take each outcome, I multiply by its probability, and then I add it all together. And so my expected value is 1.9. That's how many practices in any given week we would expect Katie to attend. Now, of course, she can't actually attend 1.9 practices, right? She could attend 1 or she could attend 2. But that's our best guess, right? That's the average number of times over the long term, over many, many, many weeks. That's the average number of practices she can attend. So if we want to pick a value that's most likely to be as close as possible to the true value, 1.9 is what we would do. Okay? What is a standard deviation? Okay, so that's the new formula. So I'm going to use the mu I already calculated together with this gnarly formula for standard deviation. Just as a reminder, it's x minus mu squared times the probability that x happened, add it all together, throw it under a square root. Okay? So what does that look like in the calculator? So our sigma is x minus your mean squared times the probability. Remember, just p of x, because I stored my probabilities in variable p of x, no parentheses here. I'm going to add all that together. So sum it all up. Notice that the parentheses here, all of this is in between those sum parentheses. Okay, I want to add all of that together. And then I want to take the square root of all of that. So again, I make sure all of that's in between my parentheses so the computer knows I want the square root of all of this. Okay? That's going to give me my standard deviation, which is 0.36055551.